Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 5.3, which is going to deal with side, angle, side, triangle congruence. So yesterday we talked about angle, side, angle, where you had to have two angles in the included side. Today we're going to talk about side, angle, side to prove triangles congruent. So this is the second of our triangle congruent shortcuts in proving triangles congruent. So today we have one learning goal, and that is you will be able to prove two triangles congruent using the side angle side or SAS theorem. So that's going to be our focus for today, determining if triangles are congruent based off of side angle side. Now, the side angle side congruence theorem states if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So, for today, what we are looking for is two sides and the included angle. So that's what our focus is today, to be able to prove two triangles are congruent. Now, to give you an example, it would be if I know that this side is congruent to this side, and this side is congruent to this side. What I need is the angle that's in between those two sides, or the angle that's formed by those two sides. So that would mean this angle needs to be congruent to this angle. So if I went through and made my notation, I know this side is congruent to this side to this side, and this angle to this angle, thus giving me side, angle, side, side, angle, side. So yesterday was angle, side, angle. Today is side, angle, side. So that's what you're going to be looking for, is two sides and the angle in between those two sides. If you can state that, then you can state that the two triangles are congruent based off of SAS. Alright, so with that said, let's go ahead and take a look at example 1. Example 1 today is similar to example 1 from yesterday, where we're just going to go through and determine whether the triangles are congruent and then state how we know that. So we're looking at side, angle, side, so I need to be able to say two sides and the angle in between those two sides to be congruent. Alright, so if we look at A, so we have triangle JLK and triangle MNP. So we need to go through and determine if these are congruent. So we need to determine if two sides and the angle in between are congruent to each other. So let's first start with a side length. So I know JK is 74 inches, and then in my other triangle, I know that NM is also 74. So because JK and NM are 74, that means that I know they are congruent to each other. So I can say JK is congruent to MN. So that is my first set of side lengths, so I know that I have a side now. Next, let's go ahead and look at another set of sides. So I know that JL is 46 inches, and I know that MP is also 46. So because these both are 46, that means that I can say these are congruent to each other. So I can say JL is congruent to MP. So I now have my two sides. Now we have to ask ourselves, is the angle in between those two sides congruent to each other? So if we look at the angle in between these two sides, that's going to be angle J. So angle J is 37. Does the angle in between over here also equal 37? So that's angle M. They also tell me M is 37, so I know that these two angles are congruent. So I can say angle J is congruent to angle M, thus giving me an angle. So can I say that these two triangles are congruent based off of side, angle, side? I can, because it goes side, angle, side, side, angle, side. So that means I have my two sides and the included angle. So I have my two sides, the angle in between those two sides is congruent. So I can say that yes, they are congruent by side, angle, side. So that is your goal for today, is to determine if you have two sides that are congruent and if the angle in between those two sides is congruent. So if we look at B, to continue this idea, for B, and I'm going to do a little bit less writing and notating, just kind of more explaining. For B, I know that DE is the same measure as HG because they're both 2.5. So I know this side is congruent to this side. Then I know that DF is congruent to GJ because they're both 1.7. So I now have my two sides. Is the angle in between those two sides also congruent? Well, they show based off the congruent mark that angle D is congruent to angle G. So I have successfully stated that I have two sides and the included angle are congruent. So that means I can say yes, they are congruent by side, angle, side. And if you want to know the specific parts, so I'm saying that DE is congruent to GH, angle D is congruent to angle G, and DF is congruent to GJ. So knowing all of that, I can then say that these two triangles are congruent based off side, angle, side. Again, you need to have two sides congruent, and the angle in between those two sides also has to be congruent. Alright, so that is example 1, part A and B. Now there are a few more parts for C, D, E, and F for this example, and I just want to go through and talk about each of them because there's a little something different about each one of them. Alright, first let's take a look at C. For C, so we have triangle ABC and triangle DEF. We have to go through and determine if they're congruent. Well, I know that AB is congruent to DE because these are both 20 centimeters. And I also know that AC is congruent to DF because they're both 19 centimeters. So 20, 20, 19, 19, so I know that both of my sides are congruent. So then you have to ask yourself, is the angle in between the two sides also congruent? So my angle between the two sides is 43 and 45 for A and D respectively. Now, because A is 43 and D is 45, these are not the same measure because they're not equal to each other. So that means that these two triangles are not congruent. And I know they're not congruent because angle A is not congruent to angle D. Because A is 43, D is 45. They are not the same measure. Therefore, I do not have my included angle between the two sides congruent as well. All right, now if we look at D, E, and F, if you notice there's no numbers, there's no letters involved as well, but we can go through and determine if they are congruent. Now, one thing I just want to make a quick note that's going to pop up in D, E, and F. If you notice, they all share a side length. Whenever you have two triangles that share a side length, and I talked about this in the proof for the notes in section 5.2, when they share a side length, that means that they are congruent, that side length, based off the reflexive property. So if I quickly just go through and say that this side is congruent to itself, this side is congruent to itself, and this one is as well, that's going to set up to allow us to determine if I can say based off SAS if they are congruent. All right, so for D, okay, I know that this side is congruent to itself based off the reflexive property, so I have a side. They tell me this angle is congruent to this angle, so I have an angle. And then they tell me this side is congruent to this side. So can I say, based off SAS, that these two triangles are congruent? Well, I have two sides and the included angle, two sides and the included angle. Therefore, I can say yes, they are congruent by side angle side. So the triangles for part D are congruent. And then if we look at E, so again, I know this side is congruent to itself based off the reflexive property. So I have a side. They tell me this angle is congruent to this one. And then they tell me that this side is congruent to this side. So knowing all of that, I have my two sides and the angle included between those two sets of sides is congruent as well. So I know that these are congruent, again, by SAS. And then lastly, for F, again, I know these sides are congruent. These sides are congruent. And then the angle in between both the sides is also congruent. So the triangles for F are also congruent by side angle side. So every set of triangles on this set of notes is congruent outside of example C. And I know that they're not congruent because the angle in between is not congruent. So that should give you a variety and get you some practice on identifying if two triangles are congruent based off side angle side. So determine if you have two sides that are congruent, and then if the angle in between the two sides is congruent as well. If you can say that, then you can say the two triangles are congruent today. All right, so that is our second shortcut, and that's practice using it. Now, just like we did with section 5.2 notes, where example 2 talked about what additional info do we need. Okay, I want us to practice that today. And then there is a series of 2-column proofs after that for our notes. So, example 2 wants us to state what additional information do you need to prove the two triangles are congruent based off SAS. So, if we look at A, for A, they tell me that angle B and angle H are congruent, so I have an angle. And then they tell me that the side AB is congruent to the side IH. So I have an angle and a side because I want to prove it based off SAS. So I have a side and an angle. That means I need to know which side I need to go with. So the question is, do I go with AC or BC to get this to accomplish side angle side? Remember, we need the angle to be included between the two sides. If I went with AC, okay, the angle they give me of B is not in between those two. So I want to go with the side BC because it's going to include the angle B. Just like over here, I want to go with HG because it's going to include this angle, whereas if I went with IG, it would not include the angle. So that means I need to know that BC is congruent to HG. All right, and then lastly, for part B, so they tell me that the side XY is congruent to the side JK. They also tell me that XW is congruent to KL. So I now have two sides. To be able to accomplish, to say based off side angle side, these two triangles are congruent, it means I need to know an angle, and specifically the angle in between the two sides has to be congruent. So if I know these two sides are congruent, that means I have to go with angle X and K, because that would give me my angle that is included between the two sides. So that means I need to know that X is congruent to angle K to say that the two triangles are congruent. Okay, so with that said, that is it for example 2, and going through and finding what additional information we need to know to prove triangles congruent by side angle side. So we have talked about how to prove or determine if triangles are congruent or not using side angle side. We've talked about what additional information we need to know to prove them by side angle side. Now the final example is asking us to go through and complete the following proofs, and we're going to use side angle side for this. Now, I am not going to run through all 3 of these proofs. Okay, I'm going to run through one of them and then use my completed notes to talk about the other 2. So let's run through one of them together, and then I'll highlight why I did what I did for the other 2. All right, for example 3, okay, part A, we have given BD is the perpendicular bisector of AC. So that's the only information they give us, and they want me to prove that these two triangles are congruent to each other. So the first statement is that BD is the perpendicular bisector of AC. How do I know that BD is the perpendicular bisector of AC? Well, I know that because that was given to me. So my reason is given. Next, they say AD is congruent to DC. Now, before I kind of jump in too far with this, a perpendicular bisector states that the two lines, so BD and AC, okay, if BD is the perpendicular bisector of AC, they cross at a 90-degree angle because the two lines are perpendicular, and BD is the bisector of AC, so it cuts AC into 2 equal parts, meaning AD is congruent to CD. So that gives me AD is congruent to DC. How do I know that these two are congruent to each other? Well, I know that BD is the perpendicular bisector of AC, and based off the definition of a bisector, I know that it cuts it into two equal parts. So definition of bisector states that whether it's a point, a line, array, whatever, it cuts that segment into two equal parts. Now, the next part is stating that angle BDA and BDC are congruent to each other. So they want to know, how do I know these two angles are congruent? Well, if this is 90 degrees, that means this is also 90 degrees. And I know that based off the definition of perpendicular lines. And I'm not going to be able to get perpendicular fully in. But the definition of perpendicular lines states that two lines cross at 90 degrees. I know BD is perpendicular to AC because they told me. So it means this line crosses this line at 90 degrees. If this is 90, that means this is 90 as well. And then lastly, for BD being congruent to BD, I know that this segment is congruent to itself because they share the side, and whenever we have that, or we're saying something is congruent to itself, we use the reflexive property as our reason. Again, anytime that you say something is congruent to itself, whether it's an angle measure or a side length, anytime you see BD is congruent to BD, A is congruent to A, BC to BC, whatever it may be, anytime it's congruent to itself, you use the reflexive property. So, with that said, how can I say that these two triangles are congruent? Well, I've determined that I have a set of sides and the angles in between, which allows me to say side, angle, side, side, angle, side. So my reasoning is side, angle, side. And that is my proof for part A. So again, use different definitions you know. So a bisector cuts a segment in half, and also perpendicular means they cross at 90. In reflexive, we're going to use any time that you say something is congruent to itself. Alright, so with that said, I'm just going to pull up my completed notes and talk about the final two proofs and why I did what I did, instead of going through and writing them out step by step. So if we look at our second proof, they state CD bisects AE, so that means this line cuts this line in half. Well, if I know it cuts it in half, that means I know this part is congruent to this part based off the definition of a bisector. And they also state that AE bisects CD, so that means this line cuts this line in half. So that allows me to know that this segment is congruent to this segment based off the definition of a bisector. So I now have two sides are congruent. I just need to know the angle in between is congruent as well. To be able to say that these two angles are congruent to each other, again, I have two straight lines that cross. Opposite angles are congruent to each other because they're vertical angles. So my reason for saying ABC is congruent to EBD is because they're vertical angles, because when you have two straight lines that cross, opposite angles are congruent. So I now have a side, angle, side, which allows me to say these two triangles are congruent based off SAS. Alright, and then my last proof on the set of notes. And I highly suggest you definitely have the completed notes up to use as a reference during the homework, because I generally try to do proofs that you might see in the homework. So I'm given AB is congruent to AD, so that means I know this segment is congruent to this one because they told me. Then it wants to know, how do I know angle 1 is congruent to angle 2? How do I know these two are congruent to each other? It's because they gave that information to me, so that's given. And then how do I know that AC is congruent to itself? So AC congruent to AC. Well, I know something is congruent to itself based off the reflexive property. So I now have my side, angle, side, side, angle, side. So I can say these two triangles are congruent to each other based off SAS. Alright, so that is it for example 3, and that's it for our notes today on section 5.3, dealing with the side, angle, side, triangle congruency. So we have now talked about two triangles being congruent in general by knowing all three angles and all three sides having a corresponding part or pair in the other triangle. We also talked about angle, side, angle. And now we have talked about side, angle, side. So we talked about triangle congruency altogether. And today we just completed talking about our second shortcut to proving triangles congruent. So with that said, that is it for our lesson today. If you have any questions, as always, you can shoot me an email or just let me know next time you see me. And I'll be more than happy to explain something or go over something if you need. But otherwise, that is it for today. I hope your homework goes well. If you have any questions, let me know. Be sure to have the completed notes up and reference them as you work through the homework. And that is it for today. So I hope you have a great day, and I'll talk to you guys later. All right, bye.